Okay, hello guys again. Now we're getting into a little bit of, you know, more substantial things here. Uh, the problem, it says, expresses force in Cartesian vector form, determine the resultant, find the magnitude and coordinate direction angles of the resultant force. In other words, decompose or resolve or find components of, in this case, there are only two forces, right? F1 and F2. That means express every force in Cartesian components, IJK, add per axis, meaning everything that goes in I, everything that goes in J together. 3, find resultant, and then you can get magnitude and direction. And this is pretty standard. I mean, same thing that we did in 2D, we're going to do it now in 3D. Just a quick disclaimer, this is a really bad drawing, and it's very difficult to understand like that. But let me try to explain it to you. These are, let's see, I don't know if I have white out here, all of my stuff, maybe, someplace. Yeah, there's one over there, white out. I'm gonna get that white out here. I'm gonna wipe this thing out of your life, hopefully. This is not correctly written here, this is really bad. So that is gonna disappear from here. Yeah, that angle over there is just misguiding the students because the 45-degree angle is not that one, it's this one. And in this case, it doesn't matter because it's 45. And sine and cosine, is the same thing. But I really don't like this drawing. Bottom line, you see, whenever you have these shadow figures over there, those shadow figures are projection angles. Those are completely different than direct or cosine angles. These angles for F2, they're pretty clear. You see, from the axis to the force, from the axis to the force, from the axis to the force. That means this is alpha, this is beta, and this is gamma, x, y, z axis. But these are projection angles. So if I want to find the components for the force one, I need this component that will be in the y direction. I need this component that will go in the x direction, and I need this component that will go in the z direction. So this will be F1z, this will be F1x, and this will be F1y. So if we work with the force 1, look what is happening. This force is like that in the space. The first thing that you have to do is bring that to the plane. You are going to make that force fall to the plane. In other words, you are going to find this intermediate step here, which is just a projection of that force over the plane. And then this projection, I'm going to take it to this side and to the other side. That's the way you do that. So let's start with F1. F1 is 300, and no problem with that. But then if I'm going to find X, which is this one, the first step, intermediate step, is finding that line, that projection. And that projection is just cosine of this angle, 60 here. Cosine 60. Once I have that cosine 60 here as direction, I have this other one, and I have this other one. This is the one that I call F1y, and this is the one that I call F1x, and this is 45 degrees. Guess what? This is a 90-degree angle, and now if I need to find F1y, I just have to project this one, into the axis. And this will be cosine because it's adjacent to the cosine. So cosine of 45 for the y. But if I want the x, which is this one, that will be sine of 45 because it's adjacent, opposite. Sine 45, that will be cosine 60, and then sine 45. For the y direction, and look what's happening also here. This force in the x direction is going in. So it's going in into that way. And the positive direction for x is this one. So that means that if the force is directed in that way, that's going to be a negative component right there. This is the trickiest part of these problems. These are the trickiest part of these problems. Now for y, same thing. It's going to be first bring it down and calculate this one, which is going to be cosine 60. This is going to be I, of course. Cosine 60. And now bring it to the side, which is going to be just cosine 45. Cosine 45. And as you can see, this is pointing in the positive direction, so it's going to be positive. And we are ready with these two coordinates. Well, the z coordinates is the easiest one because it's just this one. So for this one, the only thing that I have to do is get the 300 and multiply by the sine of this angle. Sine of 60 in K, and this is J. And of course, pointing up will be positive for that one. Now we have the force, basically force 1 in Cartesian. So let's express the force in Cartesian as it should be. Negative cosine 60 times sine 45 times 300. That will be the x component, negative 106.07 in the I direction. For the j direction will be cosine 60 times cosine 45 times 300, and that will be 106, but positive this time, 0.07 in the j direction. And in the gamma direction it will be only sine 60, so it will be 300 times sine 60, and that will be 259, no, 259.81. Okay, and we already have the force F in Cartesian notation. For the force 2, the things are easier because the force 2 is just alpha, beta, and gamma, and the magnitude of the force is known. So force 2 will be just the magnitude of the force, which is 500, I'm sorry, 500, multiplied by cosine alpha. Remember, alpha is with the x-axis, cosine 60 in I direction, plus cosine beta, which is just 45 with the y-axis, plus cosine gamma. Now this angle gamma here, you can see gamma, that's 120. And it's already telling me that it's pointing downward. When I calculate the cosine, you're going to see that. So F2 is going to be 500 cosine 60, which is sine 30. So it's going to be 250 I cosine 45 times 500 cosine 45 times 500. It's going to be 353.55 in the j direction. And now cosine 120 times 500, that's going to be negative 250 in the k direction. And that will be the force 2 in Cartesian notation. If I want the resultant force, the only thing that I have to do is add F1 and F2. In the x direction, everything that goes in I goes together. Everything that goes in J goes together. So in other words, I have 250 minus 106.07, and then I have 143.93 in the I direction. In the J direction, it's going to be this plus this, 106.07 plus 353.55, 459.62 in the J direction. And in the K direction, it's positive barely, but it's positive. It's going to be 259.81 minus 250 is going to be 9.81 in the K direction. So this is going to be the resultant force. Magnitude of the resultant force. Magnitude of the resultant force. Just going to be a square root. Out of focus. Focus again. It's going to be the square root of the summation of the square of the components. 143.93i plus 459.62j squared. So you don't put the I anymore. Squared, squared, 9.81 squared. For a total resultant force or magnitude of, I don't know, I'm getting tired. 459 squared plus 143.93 squared plus 9.81 squared. Square root of that, elevated to the 0.5. You get 481.73. That will be the magnitude of the force in newtons, the resultant force. Now the second part is find the magnitude, we already done, and the coordinate direction angles for the resultant force. Remember, we said cosine alpha I, cosine beta j, cosine gamma k. Now, because these three angles, alpha, beta, and gamma, they form basically like a box, then we can say it, and check the lecture, please, the lecture of cosine directors, that cosine alpha is just the f I component divided by the magnitude of the resultant force. Cosine beta is the magnitude of the j component of the force, or the j component, not the magnitude, divided by the magnitude of the resultant force. And cosine gamma will be the component in the z direction divided by the magnitude of the force. So we can do that pretty easy, because we can say cosine alpha equals, I'm trying to save paper and don't kill more trees, it's going to be this value, 143.93 divided by the magnitude of the force, 481.73. That's the cosine alpha, meaning alpha will be 143.93 divided by the value that I got before, is this one here. That will be no, 143.93 divided by the value that I got before. That will be the cosine, and the inverse cosine of that will be alpha, 72.62. That's alpha. For beta, I'm sorry, I'm going to put it here. I know it's too crowded, but cosine beta will be the magnitude, not the magnitude, the value of the j component, 459.62 divided by the resultant force magnitude. So beta will be the inverse cosine of that, 459.62 divided by 481.73. That's the cosine of the angle. And the inverse cosine will be 17.43. That's beta. And last but not least, cosine gamma is going to be the K component divided by the magnitude of the resultant force, and that will give you a gamma of 9.81 divided by 481.73. Inverse cosine of that will give you an angle of 88.83 degrees. So what is the answer in this bunch of weird things that we have here? Magnitude of the resultant force, alpha, here, beta, and gamma. Those are the cosine directors for the resultant force. That's easy. It's not complicated. It's just the same thing, alpha, beta, and gamma. The only thing that I added in this problem that is not new, because you already covered the lecture, is this. Cosine alpha is the value of the coordinate in I divided by the magnitude. Cosine beta is the value of the coordinate in J divided by the magnitude. And cosine gamma is the value of the component in Z divided by the magnitude. That's it, nothing else. I hope the next one is going to be better than this one.